thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello everyone. Thank you for joining us of week 33 of Oxygen Concentrator Talk, brought to you by Oxygen Alliance. My name is Sharon Ngozo. I'm currently in Nirongo, Malawi, and I'm so pleased to be hosting the call today. I'm joined by my colleagues, Mawi Lungu and Ama Prilai, alongside our usual technician from OpenO2 and Sunlight. On our technicians panel today, we have Paulina Mohoto, Masofa Mojaji, Kowinda Singh, Francis Sambani, Fatani Tamandigani, and Kevin Said. For those that may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time. And we talk about oxygen concentrator assessment, maintenance, and use. If you have any questions about oxygen concentrator maintenance or assessment, we encourage you to send it to us in advance through our email, oxygenalliance.org. If you have any question for us during the call, we advise you to post in the chat, or you can raise your hand and ask your question. So, as always, today we also have the topic of interest, and today Francis will be telling us about his experience on his trip that he had at Lesotho, where he was conducting oxygen concentrator repair training. Now, to jump into our questions. The first question says, I'm repairing an oxygen concentrator that doesn't output an oxygen. I disassembled it and discovered that the solenoid valves were not operating. When I checked the control board and tested the voltage to the valves, it was 24 volts DC, which is what the solenoid valves need. How can I fix this issue? I asked Fatani to answer this question.
Thank you, Sharon. So first of all, you have to test the solenoid valves to see if they are working or not. The solenoid valves have a functional solenoid coil that can become worn out. So conducting a resistance test on the coils is the simplest approach to determine whether a solenoid valve has failed or not. So you can check the solenoid valves using resistance test by performing the following actions or steps. First of all, you have to select your ohms range on your multimeter. You can set the multimeter to maximum range if it is not automatic, as you can see there on the graphics. Then you need to locate the solenoid pins on your solenoid valve. These are the pins which receive voltage directly from the board. And then you have to place the multimeter probes across the solenoid coil pins. Then you have to check the multimeter's reading. Usually the resistance of a functional solenoid coil typically falls within a specified range. This range varies across manufacturers, but it is unquestionably not zero. 0 ohms on the multimeter indicates that the coil has shorted. If the coil is open, then it means the wire inside is broken, and this will show on the multimeter as open line or OL. So sometimes after performing these steps, you may find that there is a normal read on the digital multimeter, but the coil is actually not functioning. So what can you do in this case? At this time, you can use a screwdriver and put it near the armature of your solenoid valve. Then you need to energize the solenoid coil with its rated voltage. In your case, you say it's 24 volts. So you have to energize the solenoid valve with 24 volts. If the coil is working, it is supposed to create an electromagnetic field, and it will attract the screwdriver. If no magnetism is detected, then it means the coil is bad. So what to do if you find out that the coil is bad? In this case, you must buy new solenoid valves if the test shows that your current ones are defective. Although you can change the coil, it is not advised because doing so could result in your concentrator having further issues. The improper material is used. So buying a new valve is your best option. However, when purchasing a new valve, you must make sure that the solenoid valve you purchase has the same exact voltage and current rating as the one that is defective. Thank you. Over to you, Sharon.
Thank you very much, Batani, for that explanation. Any comments from the technicians or questions from the audience? Okay, so at the end of this question, we have a poll. I'll ask Amapri to run the poll.
Yes, and while I'm launching the poll, do you want to explain how to access the polls?
Yes, so I will help out with that. So if you're joining us using your mobile phone, then if you go to the bottom right of your screen and you click on the menus option, a window will open up where you have a couple of options. The activities button is one of those options. If you click on that, another window will open where the pause menu is one of the listed options. If you're joining us using your laptop, then you just go to the far right of your screen. The icon, the last icon you have on the far right is the activities button. If you click on that, a window will open and that will take you to a window where the pause menu is one of the listed options.
Thank you, Maui. So the question is, have you ever tested the resistance of a solenoid valve before? And it looks like most people that have answered yes. So back over to you, Sharon.
Thank you very much, Amapri. So if we have no further question from the audience and no comment from the technicians, we move on to our next question. And it says, I'm a biomedical technician and working on an oxygen concentrator. The oxygen concentrator turns on, runs for a while, a maximum of 20 minutes, heats up and shuts itself off. What could be the cause of this problem and how can it be solved? I'll ask Kevin to answer this question.
Thank you, Sharon. The most obvious cause of this problem is that your motor is running too hot. So in most cases, it is your cooling fan that has failed and you need to replace it. But in very rare cases, if you have just installed a new start capacitor, you could have installed the long value capacitor. And if a long value capacitor is installed, the motor will not have an even magnetic field. And this will cause the rotor inside the motor to hesitate at those spots that are uneven. This hesitation will cause the motor to become noisy. It also increases energy consumption. It will cause the performance to drop and cause the motor to overheat. So in either case, once the motor overheats, the thermal protection switch will shut down the compressor until it cools off. This problem will not go away and the failed component will not to be ultimately replaced. Thank you. Over to you, Sharon.
Thank you very much, Kevin, for the explanation. Any comments from the technicians or questions on capacitor and cooling fan? Okay, I have a comment. Every time you're operating an oxygen concentrator, make sure that it has to be far from the wall or anything else that can obstruct it, because it can also be a reason why your concentrator can overheat. Now we move on to our next question, and it says, a Cantor V8 oxygen concentrator was brought to the workshop and it had low and fluctuating purity. I checked for gauges and I did not find any. I then serviced the compressor and there was an improvement in the purity, but not by much. We usually refill zeolite in our workshop, and we have both sodium and lithium zeolite. I used a ratio of 70% lithium and 30% sodium to refill the sieve beds, but the purity only went up to 85%. This was my first time working on this model, and I believe the problem was the ratio used. What ratio can I use, and how can I determine what ratios or types of lithium to use in other oxygen concentrator models? I'll ask Maui to answer this question.
Thank you very much, Sharon, for the question. So there are two main types of molecular sieves for oxygen concentrators on the market. And these are the sodium type and the lithium type of zeolite. So the lithium type of zeolite is more efficient than the sodium, but because the sodium is way cheaper compared to the lithium, it is very popular, especially amongst the oxygen concentrators. So to answer your question, it is okay to use both the lithium and sodium type molecular sieves in oxygen concentrators. For the lithium, so you should make sure that it's always placed at the top, sorry, and the sodium should be placed at the bottom. So in this case, the bottom is the side where you are having the air coming in from the compressor going to the sieve bed. So always you need to make sure that your sodium zeolite is where you are getting air pumped in from the compressor. And this is so because sodium zeolite is a desiccant, meaning that it will soak up air and moisture from the air around it more efficiently compared to the other one. It's also done this to protect the lithium zeolite. And during the purging process, the nitrogen takes away the moisture from the sodium and sends it back to the atmosphere. So this protects your lithium zeolite. So an added benefit to this is that the amount of zeolite used is reduced, which slightly reduces the cost of maintenance on the concentrator. So in your case, the Cantor V8 is an 8-liter model concentrator and therefore requires a lot more lithium. So one of the advantages of lithium zeolite over sodium is that it can be used in concentrators with larger flows. So it normally ranges from 1 to 20 liters per minute, while for the sodium type, you're only restricted to 1 and a maximum of 5 liters per minute. So I would suggest you, when you're refilling the sieve beds, you try to change the ratio to either 90% lithium, 10% sodium, and then you observe the purity that the concentrator gives out. And if it gives you the desired results, you can then try to lower the ratios so that at least you use less of the lithium and more of the sodium, and do that slowly and then see which ratios still gives you the desired results. So you can do the same for all the other versions of concentrators. Thank you very much, Sharon.
Thank you very much, Maui, for the detailed explanation. Any additional comments or questions from the audience to Maui about zeolite? If we have no question, we have a poll at the end of this question. I'll ask Amapri to launch the poll.
Yes, our poll question is, have you ever mixed lithium and sodium zeolite when refilling sieve beds before? And while we'll give everyone a little bit of time to answer that question, but I think this is something that's actually relatively new in terms of mixing. I know sodium zeolite is generally cheaper, but most manufacturers use one or the other. There's only a few that use both. So it's interesting. I'm curious to see what the answers to this question are and to our poll question will be. And I think it's very 50-50. And maybe that's something that as the Oxygen Alliance, because it is a slightly more complex situation, maybe that's something that we can cover in more detail on a future topic of interest on how to do that. or why to do that. So thank you, Mwawi, for your answer. And back to you, Sharon.
Thank you very much, Amapi. Now we move on to our next question. And it says, we serviced one Perfecto oxygen concentrator 2 weeks back, rebuilt the compressor, serviced the four-way valve, and replaced sieve beds and filters. The machine worked fine, giving purity above 95% at flow setting of 5. Now we have received a call that the machine is giving a low purity alarm. Can you please suggest what can be the problem? I'll ask Fatani to answer this question.
Thank you, Sharon. So, as pointed out in your question, you said the machine was perfect to service 2 weeks back. So there's a very low probability that the main parts, that is the compressor, sieve beds, or the four-way valve, have any problems. So to do away with your issue, you can perform the following steps. First, you have to check proper ventilation to the concentrator, check the functioning of the cooling fan. Sometimes there is a possibility that some creatures like rats or lizards may enter the device and strike into the fan. In this case, the fan stops working, thereby increasing the internal temperature of the concentrator. So it makes it very tough for the concentrator to draw oxygen from the heated air. If you find everything is okay with the cooling fan, then the next step is you can check for loose connections and the leakages. The second step that you can perform is you have to check thoroughly for loose connections or any possibility of leakage in all connecting points. First, you have to check out the cooling tube or the connect tube that connects the compressor and the four-way valve. You also have to check for leakage between the four-way valve to the sieve beds and also the connection of PE, that is pressure equalization valve, between the sieve beds. You also have to check that connecting points for leakages. Also, you can check the multiple connections on oxygen tank, including the pressure regulator that is positioned just above the oxygen tank. Then you can also check the connections on the control board. And at 5, if the formula is open and the bore is above 5, then the concentrator is giving more flow, and this can also affect the purity of your oxygen coming from your concentrator. Thank you very much, Sharon.
Thank you very much, Fatani, for the explanation. Any questions from the audience or comment? Okay, just a reminder for our new members, we ask you to share with us your contact details in the chat so that we can add you to our mailing list. So moving forward to our next question, it says, there is an ASAP intensity 10 concentrator in our workshop, which is performing well. The only problem it has is that the check valve, which is found between the concentrator outlet fitting and the flow meter outlet port, is broken. I want to replace the check valve, but the spare check valves, which are in the workshop, are not exactly the same as the broken one. Can I go ahead and replace the check valve with the ones we have in the workshop? I'll ask Masofa to answer this one.
Thank you, Sharon. The first step you need, the first thing you have to put into consideration is that oxygen concentrators have different output pressures. ASAP intensity 10 and intensity 8 concentrators have higher output pressure when compared to other concentrator models like the Vilbis and Longfien concentrators models. The output pressure for ASAP intensity 10 is 138 kPa, which amounts to 20 psi, while the output pressure for Longfien and the Vilbis models is 40 to 70 kPa, which amounts to 5.8 to 10 psi. Therefore, if you replace the check valve with the one that cannot withstand such high pressure, it will break. So I recommend that if you have any ASAP intensity concentrator in your concentrator graveyard, which you can scavenge parts from, you should get a check valve from there and replace the broken one. I would also recommend you to use the generic valve as long as you are certain that it will withstand the pressure as high as 20 psi. Thank you.
Thank you very much, Masofa, for that more detailed explanation. Any comment from the technicians or questions from the audience? Amapril, have a hand.
Yes, I have a comment. Thank you, Mova, for the answer to that question. I wanted to add some more information. So the airstep in the 10 liter is a 10 liter concentrator. That's why it has a higher PSI for the outlet pressure, because you need the higher amount of flow to reach the patient. And if you're talking about more than 5 liters, if the pressure is high enough, all of the oxygen that you want to reach it will not. So the 10 liter device also has PSI of 20 for the same reason. I think in Profa's explanation, there's just a little bit of mixing between 5 and 10 liters. I think it's important to understand why there is that high and what the difference it makes. Or actually, because I think when it comes to using oxygen concentrators in hospital settings, which is very common in our areas, having that higher PSI outlet means that you can actually use it in a lot more ways successfully. So sometimes you may find in your hospitals, if it's a concentrator without that higher PSI, within the hospital setting, the patient isn't saturating. But if a patient is using a device like the AirSep Intensity 8 or 10 or the DeVilbiss 10 liter, your patient outcomes can be better because of that PSI. So it's an important thing to be able to fix and fix correctly, because it does make a difference for patient outcomes. Thank you, Sharon.
Thank you very much, Amabri, for the comment. Any other comment or questions? Okay, if we don't have comments or questions, we take a slight diversion to our topic of interest. So as I said earlier, today Francis will be sharing with us his experience at Lesotho, where he went to train on oxygen concentrator repairs. So over to you, Francis.
Thank you, Sharon. So today we'll be talking about the training that we had at Botshabelo Hospital in Lesotho. So we started our trainings on 1st September. Maui and I traveled to Lesotho to conduct the technical training on troubleshooting and repair of oxygen concentrators in Maseru. The training was conducted in a space of 2 weeks, and the training involved 21 people who are working as technician officers, as electricians, or plant operators, and or mechanical technicians. So from the graphics, we can see the team that was involved, including us, as well as the biomedical engineer for PIH in Lesotho, Maseru. So the education background played a good role in our training, as these people either had electrical background or biomedical backgrounds, and it made our training comparatively easier and the exchange of information smooth as well. And recently, they had been trained on the PSA plant in terms of its maintenance and also its operation. So it was easier for them to grasp some other concepts of operation as well, because the oxygen concentrator is also a PSA machine. Before we started our trainings, we had prepared a pre-test, and it had a lot of electrical related problems. So this was done so that we know the electrical knowledge level of the trainees, so that we have an idea of how to proceed with the trainings. On average, they fared well, and it was around 72%, which was not a bad start, and showed that they had basic knowledge required for the training itself. And then we went on to teach the theory of operation of oxygen concentrators and troubleshooting steps for common oxygen concentrator problems. After the theory part, they also had another test to see if they had assimilated or they had gotten most from what they were taught. And they fared much better, averaging 88%, showing that they got most from what they were taught. The class seemed to be very attentive, as evidenced by the questions they were asking. They also seemed eager to learn more from the SAM. All in all, it was a nice interactive session of sharing each other information, and we also learned one or two things from them. Going on to the nature of the training itself, the training was divided into 3 stages. The stages are classed as one, the theory part, and then the shadowing session, and also the hands-on session. So we know, some of us probably know the common saying, which goes like, teach me and I may remember, but then if you involve me, I will learn. So when you just try to explain the theory is involved on different concepts or principles of working on the oxygen concentrator. They may get the things, but then they may easily forget. So only when you involve them or involve people, that's when they may get to learn more and easily understand the thing firsthand. So that's why we had to have the hands-on session and also the shadowing session. Going into detail, I'll try to talk about the theory part of the trainings. And the theory part involved the common parts and the theories of operation of an oxygen concentrator. So this explains what you're likely to find across almost all models of oxygen concentrators and how these individual parts work hand in hand in order to produce air that is rich in oxygen. Then we want to talk on about the common faults experienced with oxygen concentrators and how one can deal with these faults stepwise. For example, if the concentrator would not power on, the first thing that they would have to check would be if there is power from the power outlet or if the reset switch on the oxygen concentrator had tripped and open circuited the concentrator. So they had to either use a multimeter to see if there's power or use a non-working power outlet to see if the problem isn't with the power outlet or it's with the concentrator, that is. Then if they still see that they have a problem, they had to move on to check the power cable to see if that's the problem. So on checking the power cable, what they'll do is that they'll have to check the fuse or check the continuity of the wires. So some kettle cables would either have 3 wires, that is the earth, live, and neutral, but some only have 2, the live and the neutral. So they'll have to check those wires depending on the design of the kettle cable itself. So if after that they find that the cable is okay, the outlet is okay, but then the problem is still persistent, they'll have to go on and check the fuse of the oxygen concentrators, because some oxygen concentrators have a fuse on the connector of the kettle cable itself, like the J5. So they have to check that to see if that fuse isn't compromised using the continuity meter itself. And if still there's a problem, they would have to go on to the control board and see if the fuse on the control board is damaged or not, or if other components on the control board, not the fuse, are blown out, which would short circuit the concentrator or no, and make the concentrator not power on. So they would all have to use a continuity meter or a voltmeter to check for voltages or open circuits, I should say, on the control board. So the importance of this step-by-step troubleshooting is that it helps to save time. It doesn't let you go forward or something or the problem, or you've left the problem behind. So the step-by-step troubleshooting technique is actually quite good, as in saves you time. Yeah, so that was why we had to take them through these whole processes. So in the graphics, you can see from the 2 pictures, you have Maui on the picture on the left presenting to the people. Yeah, and then you have me on the second picture presenting to the people as well, the trainees. So that was during the theory section of the training. And moving on, we had the shadowing session. So the shadowing session involved the trainees being directed on how to proceed with the troubleshooting process. the trainees were divided in groups of 3, and each picked up the concentrator to work on. As the trainers had to be there to demonstrate and also direct on how they can go on with processes or the troubleshooting techniques. So the shadowing session simplified other explanations, like, for example, how air moves inside the compressor and how the parts work hand in hand. It was easier explaining with the compressor open, and it was also easier for the trainees to understand the concept or directly looking at the parts involved inside the compressor itself. So it was also part of the combination with the theory session as well, because we also had to go back to some other things and explain just to make sure that they fully understand the things and the concepts. And after the shadowing section, then we had the hands-on session. So the hands-on session required less guidance, and also that the trainees do most of the work themselves. So this was done so that we know their understanding of the skills they have picked up from the training. It also gave us room to only focus on what was lacking in terms of knowledge or skill, so that we try to improve on that. So they had to either check for leakages, refill beds, but then we didn't have zeolite ready available, so we demonstrated using the zeolite that was already in the safe beds. Like, we had to make sure that the humidity was low, and then remove the end cap of the safe bed, take out the zeolite, and try to demonstrate the whole process. And also they had to troubleshoot and fix other problems in this hands-on session. So from the graphics, we can see different technicians working on different things. In the first picture on the top left, we have the technicians working on the compressor. They were servicing the compressor, and on the top right, we have them refilling the safe beds. Yeah, and also we have them working on other things on the bottom left and the bottom right pictures. So this was the hands-on session, and during these sessions and also after the sessions, we had to get feedback. So on getting feedback, we had 2 types of feedback, I should say, that we got from them. So we call this first type of feedback as the in-session feedback, and the after-session feedback, the other feedback. So the in-session feedback was getting feedback while the trainings are ongoing. So we had to get what they worked on during the day, and also what they did, why they did what they did. So they have to tell us that maybe we were refilling safe beds, so they had to like explain that they were refilling safe beds, and what they had to do before refilling the safe beds. That would be like making sure that the humidity was low. Why did they have to make sure that the humidity was low in that case? So they had to explain those concepts just so that we know that they really got the concept of why, or the reasons why they were doing something, and not necessarily have the things in place like the directives, like you should just do this, but then there's a reason behind doing that thing. So they had to explain that reason. So this was the purpose of the whole in-session feedback, so that we also see where they're lacking, and also we try to improve on that. And after the these feedbacks, we also had the overall feedback. So this was the after session feedback. So this was just the feedback on the overall training itself. So we actually got positive feedback on how the training was conducted. And what I can say that I like most about the feedback was that most people said that the explanations were clear. So it is a challenge explaining to an audience and not having to use their local language, and to simplify some other explanations, because I just feel like some things are better explained in the local language itself. So, but then we had to use English all throughout, and from the feedback that we got, it seemed the explanations were quite clear and they got everything. So that was what I liked most about the feedbacks, and also overall it was a positive feedback that we got from the trainees themselves. But then during these sessions, we experienced some challenges, and some of the challenges included that we didn't receive some spares, like the compressor service kits and also the new safe beds in time. So this sort of delayed our progress as well. So this was one of the challenges that we faced. Yeah, and also the other challenge was that we didn't get the ordered zeolite during our 2-week training because of the lockdown in China. So some concentrators that needed zeolite were not refilled during the duration of the training itself. So we're hoping that, and also the plan is that they have to refill those concentrators that were marked that they need the zeolite after the trainings. And also the other challenge is that we didn't have enough tools, not enough tools were available. So we had to take tools on some, we had to take turns on some tools. Like, let's say, for example, if you're trying to service a compressor, you had to wait for one group to get done with servicing the compressor so that you can also start servicing your compressor, stuff like that. So that was also a big challenge that we faced during the trainings in Lesotho. So I'll just go on and give you a summary of the work that we had. So in total, we had 38 concentrators to work on, and from those 38 concentrators, we managed to fully fix and test 19 oxygen concentrators, slightly above half, or I think that's half actually. So we managed to fix 19 oxygen concentrators, and we sidelined, not let me not say sidelined, but then we put aside 10 concentrators that were in need of zeolite. So we fixed 19 and left 10 that we marked that this only needs zeolite, waiting for the zeolite that was ordered from China to, yeah, so that we can have it, we can have that filled in this concentrator. So those were 10. And then we sidelined 6, and the 6 that we sidelined were those that we think wouldn't be repaired. So the issues that included with these 6 was that 2 had problems with the control boards, and also the transformers were bent out. So all in all, they just needed replacing the control boards and also the transformers. And 2 of these 6 were being scavenged for parts. So as we were fixing some, we had to like make sacrifices. So these 2 were being scavenged for parts, so we couldn't fix them. And also we had 2 that had leaking seatbelts, and for these seatbelts, the Chinese seatbelts, and the design is quite different. We tried using some thread tape on them, but then it didn't work. We still couldn't fix them. So we just thought that the need would be to like change the whole seatbelt. So just get a new pair of seatbelts as well. So those were 2. So, and also, if we try to add this up, we are left with 3 from the 38. So 3 are fixable, but then they needed more work and also more time, or so yeah, this was like our summary. So I just go back through it again. We had 19 that were fixed and tested, and 10 that needed zeolite, and 6 that were sidelined because they had bigger problems. And then we had 3 that just needed more time or work. Yeah, they were worked on, but then yeah, they needed further troubleshooting. So this sums up our stay in Lesotho and our trainings in Lesotho. Thank you for the attention, and over to you, Sharon.
Thank you very much, Francis, for sharing us your experience. Any questions or comment for Francis? From the pictures, we can tell a good job was done, and the technicians seem to be very cooperative. Okay, if we have no questions or comment, we move on to our questions. The question says, I was working on 2 oxygen concentrators, one Longfian and the other AirSep. I noticed there's a valve connecting the 2 seatbelts in the AirSep and no valve connecting the seatbelts in the Longfian. So I was curious as to why there is that valve in AirSep and not in Longfian, and what is the function of that valve? I'll ask Kelvin to answer this question.
Thank you, Sharon. So first of all, that valve is called an equalization valve. It is called an equalization valve, and it's true that some concentrators employ the use of it while others do not, just like you saw in the case. So the function of the valve is to equalize the pressure across the valve. So in our case, it means to equalize the pressure across the seatbelt. When one sieve bed is being purged, meaning that nitrogen is being expelled, its pressure drops and it will require a pressure build-up when the cycle switches, and this can take a lot of time. So the equalization valve therefore takes pressure from the other sieve bed to the purged sieve bed to a certain level to avoid starting from a low pressure position. And other concentrators that don't have an equalization valve, they are designed not to have the pressure during purging fall down a certain critical value. Thank you, Sharon.
Thank you, Kevin, for the explanation. So we have a poll at the end of this question. I'll ask Amapri to run the poll.
Yes, the poll question is, did you know the function of the equalizer valve? And while everyone is going through and answering, as I think everyone has heard me say on this call many times, I am not a technician, so I did not know the function of the equalizer valve, but I did very much appreciate and enjoy that explanation from Kelvin. And it looks like everyone here who is much more technical than I am, all of our votes are yes. So that's good to see. Back to you, Sharon.
Thank you very much, Amapri. Okay, if we don't have any comment or question for Kelvin, we move on to our next question. And it says, what happens to an oxygen concentrator when a patient smokes? What happens to an oxygen concentrator when a patient smokes? I'll ask Paulina to answer this one.
Thank you, Sharon, for the question. As we all know that smoking itself is dangerous to our health, it is not advisable for people using oxygen to smoke. Smoke causes cancer, heart disease, stroke, lung disease, diabetes, and chronic obstructive pulmonary diseases, which includes emphysema and chronic bronchitis. Smoking also increases the risk of tuberculosis, certain eye disease, and problems of the immune system, including rheumatoid arthritis. So we discourage the issue of smoking to the people who use oxygen concentrators. Also, it is not permitted to use an oxygen concentrator while smoking. As we know, it's a fire hazard. Concentrated oxygen is highly flammable. Smoking affects the concentrator in many ways, and it is very dangerous to the patient. The concentrator might catch fire and cause serious injuries or even worse. Smoking also affects the components, which can be the sieve beds. The sieve beds become contaminated and their lifespan can be reduced drastically. It also causes discoloration of the tubes and the smell stays inside of the machine. So oxygen concentrators, they have like sponges inside of them, which help in the parts inside of the machine. So when there's vibrations and all of that, these parts can hit the sponges and there will be no vibrations on the machine, like harsh vibrations. So if the smell is on that sponges, so when you run the machine, you will find that you would still smell the smoke. So if the patient uses the machine, you would still smell the tobacco smell. So also smoking also voids the warranty of the machine. If the machine is under warranty and the patient is smoking, it will void the warranty, and the technicians will be able to detect that the machine was used by a smoker through those tubings and also the tobacco smell. So patients should not be smoking whilst using the concentrators. So if the patient smokes and whilst they use the concentrator, what they can do, what we advise is they will have to switch off their concentrator, go outside or go to another room to smoke, and when they are done, they can then use the machine once they are done. They should not even smoke in a room where the concentrator is being used. Thank you.
Thank you, Paulina, for that explanation. Any questions or comments? Okay, we have a poll at the end of this question. I'll ask Amapli to launch this one.
Yes, I will do so. The poll question is, do you now understand why smoking near an oxygen concentrator is prohibited? And while people are going through that, thank you, Paulina, for your explanation. I think I like the focus kind of on patient care. Of course, we all know oxygen is flammable, so smoking is a very, very dangerous thing to do around concentrators where there is that pure oxygen that's available for patient safety. Of course, all the things that Paulina said about the device as well, but we should always remember that it's about patients at the end of the day, whether they're in hospitals or at home. And it looks like all of our answers to this poll question are a yes. And back to you, Sharon.
Thank you very much, Amapri, for the comment. So if we have no other questions or comments, we move on to our next question. And it says, I was servicing oxygen concentrators, and I noticed that some concentrators, such as the AirSep and DevoBridge concentrators, have separate check valves. Other concentrators like the J5 have no separate check valves. Doesn't the absence of the separate check valves affect the performance of the concentrator at some point? I'll ask Kowinda to answer this one.
Thanks, Sharon. So there is a manifold in AirSep, DevoBridge, and other oxygen concentrators, which attach the output of the seabed to the accumulator tank. In this manifold, the seabed check valves are located between the outlet of each seabed and the accumulator tank. The function of these check valves is to allow oxygen to pass from seabed to the accumulator tank. When the bed pressure is greater than the accumulator tank pressure, the seabed check valves also prevent the reverse flow of oxygen from the accumulator tank to the seabeds. The manifold also includes a purge harness which has a fixed orifice. The orifice allows a small amount of pressurized oxygen to flow into the discharging seabed to aid in the process of purging out the nitrogen. To answer your question, absence of the seabed check valves in concentrators, say as J5 and Kanta, does not affect the performance of these concentrators because of the way they were designed. If you look at the two pipes where are attaching the seabeds to the accumulator tank, you will notice that there is an orifice between the accumulator tank and the each seabed. So these orifices allow oxygen to flow from the pressurized seabed into the accumulator tank, and also just a small amount of the pressurized oxygen flow into the discharging bed to help in the nitrogen exhaust process. So if you are to lose oxygen from the accumulator tank to either of the seabeds, when the accumulator tank pressure is greater than the seabed pressure. So it will be very small amount of oxygen since the opening of the orifice is very small or tiny. Thank you, Sharon.
Thank you very much, Kowinda, for the explanation. Any comment from the technicians or questions from the audience? So every time you're fixing a concentrator that has the orifices, for example, the AirSep, if you maybe remove the pipe that has an orifice, make sure that when you're done fixing it, you press the pipe, because if you remove those, the end result is the purity will be affected. So they are really helpful in the concentrator. If we have no question, we move on to our next question. Hello. A DevoBridge 525 oxygen concentrator that was delivered to our workshop last week indicated insufficient oxygen purity. I discovered that the zeolite in the seabed was damp after troubleshooting. After cross-examination, it was discovered that there were water droplets in the concentrator's output side tubes, as well as the product tank. Both the product tank and the pipelines have been dried. However, I worry that if I replenish the zeolite, the same issue would persist. What might be the reason for the water's persistence, and how might it be fixed? I'll ask Paulina to answer this question.
Thank you once again, Sharon. Okay, so the DeVilbiss 525 model lacks a one-way valve between the final bacteria filter and the patient outlet. When you do not have this final check valve, the water from the humidifier bottle sometimes flow back into the pipes, which is the cause of the dampness in your oxygen concentrator's output system. There is a back pressure that is produced whenever an oxygen concentrator is turned off. Water in the humidifier bottle flows into the device as a result of this back pressure. Water enters the product tank and occasionally may make it to the sieve bed, contaminating the zeolite. The one-way valve, sometimes known as the check valves, are present in several concentrators, such as the DeVilbiss 515. The final bacteria filter and the concentrator outlet fitting are separated by the one-way valve. The one-way valve closes when the unit is turned off and the oxygen flows stop, preventing water from being sucked into the device. Since certain concentrator models do not include the final check valve, you should install a one-way valve between the final bacteria filter and the concentrator's outlet fitting in order to avoid this issue from happening again. Thank you.
Thank you very much, Paulina, for that well-detailed explanation. Any comments from the audience or questions? Okay, if we have no further question, I would like to thank you all for joining us for this week's Concentrator Talk. So just a reminder, okay, Amapri, you have raised the hand. Go ahead.
Yes, thanks, Sharon. Just before you wrap it up fully, I just want to remind everyone that we have the oxygen talk next week. So the oxygen talk is when we use this same time, but we invite an expert to come in from the from something oxygen related, not necessarily concentrator related, and to give us a presentation on that. So we are very excited. Next week's presentation is going to be by Will Snyder from the D Prize. And he will be going into detail about one, and most excitingly, a funding opportunity for biomedical engineers working on oxygen concentrator repair. But two, he will also be talking about what funders look at. So when they're trying to evaluate grants, they're trying to evaluate applicants, how does a funder explore and think about those questions? So for all of us, I think, whether we're looking for an immediate grant right now, or we have many grants that are applied for over time, to hear from a funder directly about how they think and what they're doing is a very, very exciting opportunity that we are very pleased to bring to you. So we hope that you can all tune in next week. You'll see our reminders and all the emails this week talking about that. But we hope that you can all join us again next week to hear from Will directly. Back to you, Sharon, to wrap it up. I think you are on mute, Sharon.
Thank you very much. So for those who haven't shared with us the contact details, please do so in the chat so that we can add you to the mailing list and to keep reminding you. So, and for those who have questions, please send them to us in advance through our email, info@oxygenalliance.org. And also, you can visit our website at www.oxygenalliance.org, where you can learn more about the Oxygen Alliance and all our work. We also have a YouTube channel where all the previous Concentrator talks, they have been posted there. So be sure to check them out and remember to subscribe to the channel. reaching this far. Thank you for joining us and see you next week. Goodbye.